All right, class. Today our topic of conversation is factors and multiples. We got to talk about a little bit of vocab. This is going to be extremely important for you to understand the difference between a factor and a multiple. Let's go around the room, not around the room, but let's take a few people. Which one do you think is the smaller of the two? Are factors smaller than multiples, or are multiples smaller than factors? Which way does it go? Factors first. Factors are smaller than multiples, and that's going to be our first topic of conversation, factors. And then we're going to try and think up some examples. Factors. Factors are numbers that can be divided evenly into a number. Do me a favor. Somebody just give me a number, any number, but make it kind of like in the middle area between bigger. Ooh, I like 12. 12 is easy. Okay, 12. Okay, example 12. Give me the factors of 12. Factors of 12 are 6 will evenly divide into 12. What else? 3, 4. What else? 12 goes into itself, and definitely 1. Any other ones? Oh, we got 2. Yeah, that's it. Those are factors. Easy, piece of cake. All right. Now, since we're talking about factors, let's talk about the kinds of numbers that we could choose from. There are special ones called primes. Prime numbers. Prime numbers are numbers greater than 1. 1 is not included, so it's got to be greater than 1. That can be divided evenly only by 1 and itself. Prime numbers are ridiculously important in math. In fact, there is a very, 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 very big prize that you can win if you can figure out how to find the really large prime numbers. If you could figure out a formula or a strategy of finding the really big ones, you would be the single most famous and the single wealthiest person in the whole entire world. So wealthy, even Bill Gates would be jealous of you. Somebody give me some examples of prime numbers. Go. Yeah, that's my favorite one. So wait a minute. Great minds think alike, right? What about else? Give me another prime number. Not 9, because 9 is divisible by 3. But give me another one. 19 will do. Yep, 19. What about another one? Go. 2. Yep, 2. And in fact, I'm glad you said 2. This is a bit of trivia. It's a bit of trivia. Turns out 2 is the first prime number because 1's not prime, and 2 is the only even one. So if you guys are on Jeopardy and they ask this, come on, let me get a shout out. First of all, second of all, the answer is 2. All right. So the next item on the list for us to talk about, right, is something called the GCF. What's the GCF? Anybody know? It's the greatest common factor. It's the largest number that's a factor of each of the given numbers. Now, a lot of people guess at it. You know, like, I think like 6 is the biggest. So one thing we're going to work on in here right now is, if you are given two numbers, like let's say 24 and 60, how do you find the greatest common factor and make sure that it is absolutely the greatest one? Because there's lots of factors to numbers. So here's what we're going to do. Here's the strategy for always finding the GCF. We are going to prime factorize each of the numbers. What do I mean by that? I totally understand if you have never heard of that before. We're going to write 24 over here, and we're going to write 60 over here. And give me two numbers, any two numbers that multiply to be 24. 2 and 12. If one of these numbers is prime, circle it. And keep breaking the other one down. Give me two numbers that multiply to be 12. 6 and 2. 6 and 2 will work. Oh, there's another 2. That's prime. Let's keep going. How about let's break down 6 again. 3 and 2. And these are all prime. Nice. Nice. So we've got all these prime numbers. Okay. We're going to prime factorize it. Now let me write this down for you before we start on 60. prime factorization, remember I told you prime numbers are so important, and that's because 24, when it gets written, whoops, hold on one second. So when you decide to write 24 down in its prime factored form, you are essentially writing it down in a unique way. In other words, that is 24's mathematical fingerprint. There is no other number that can be written like this in this way, and that's how it's uniquely identified. What's up, Suleiman? And, all right. Now let's prime factorize. Let's prime factorize 60. Let's prime factorize 60. Give me two numbers that multiply to be 60. I'll take 30 and 2, and there's one of them right there. Give me another one. 15 and 3, right? Oh, that's right. 15 and 2. And there's another one. 3 and 5. And there are the remaining ones. And so now let's write 60 down in its prime factorized form. 60 is simply 2 times 2 times 3 times 5. That's its mathematical fingerprint. Step 2. Select the factors that appear in each. What factors appear in each? 2, 2 and, whoops. Sorry about that. The factors that appear in each are 2 and 2, and also 3. Write them down. Select the factors that appear in each. 2, 2, and 3. And then finally, multiply all those factors together that you just selected that appear in each. 2 times 2 times 3 is how much? It's 12. And 12 is the GCF. It's the greatest common factor. All right, guys, let's play a bit more. Let's play a bit more. All right, we're going to do 2 more examples. So let's do this one, 10 and 35. Let's do it. 10 and 35. 10. What's 10 break down to be? 5 and 2. And how about 35? What's 35 break down to be? 5 and 7. Do they have any, can you go any further? No, all of these guys right here are prime. And what are the common factors? There's only one of them, so that the GCF is just 5. You know what? Let's do it in a nice, good color. GCF equals just 5. Ah, that's an easy one. Here's a difficult one. 42 and 56. Let's break 42 down. Give me two numbers that multiply to be 42. 12 and what? 21 and 2. I like that one. 21 and 2, and 2 is prime. Let's break down 21. What are you thinking? Very nice, yeah. Let's do 7 and 3. Those guys are also both prime. How about 56? 7 and 8. 7's prime. Let's break 8 down. 4 and 2. And 2's prime. And then, of course, everybody knows 4. Whoops. 4 breaks down into 2 and 2. And these numbers are both prime. Okay. All right. So there you go. There's all of our prime numbers. Now, which ones do they have in common? 7 and 2, right? 7 and 2. So the GCF is going to be equal to 7 times 2, and the GCF of those guys is 14. 14 is the greatest common factor of 42 and 56. So here's our final page. This is our final idea, the LCM. The LCM. What's the LCM? The least common multiple. Which is bigger, factors or multiples? Multiples. Factors are smaller numbers, multiples are bigger numbers. Get used to thinking about that. Now, there are lots of multiples, but what's most useful to find is the least common multiple of a bunch of numbers. The smallest one they all evenly divide into. If you want to think of it, we got to find the smallest number that both 2, 5, and 6 are factors of. Does anybody know it off the top of their head? What is it? 30? Well, we're going to find out. Let's see if we could figure out a way to get it to go about doing it. To be honest with you, the only way I know about going about trying to find the LCM is to literally list multiples of each of the number until the smallest one appears. So let's do it for 2. Give me some multiples of 2. 2, 4, 6, 8, 10, 12, 14. You understand how I'm going about counting this out? All the way down, we could keep going to 30. And we could go beyond 30. We could go 32, comma. We could keep going all the way down to 100. And furthermore, it would go on forever. Oh my gosh, that would be so annoying. How about 5? Give me some multiples of 5. Good. 10, 15, 20, 25, 30. Well, we got 2 to match already. Let's see if that third one matches. 6. Give me some multiples of 6. Absolutely. Let's do 12, 18. What comes after 18? 24, 30. Oh my God. You guys were amazing. Yep. Look, they all have 30 in common. And so the LCM, the least common multiple of these numbers, is 30. That's it.